Hi, and welcome to this video segment on multiplying functions. First thing I want to bring to your attention is the function notation that you'll see when we're multiplying functions. We have f dot g of x or f of x dot g of x. They both mean the same thing. They just mean to multiply those two expressions together. So I want you to notice, however, that it is a closed dot between the two functions and not an open circle. Next time we get, not next time we get together, but later in this unit, we're going to discuss what that open circle means. But for right now, I just want you to notice it's a closed circle indicating multiplication. So to multiply functions, just like in addition and subtraction, we need to replace that function notation with the equivalent expressions. And then, of course, we're going to multiply using the distributive property. And we refreshed this in our last unit. There's something else I also want to remind you of, and that is the multiplication rule of exponents. And that states that when you multiply terms with the same base, we simply add the exponents to get the product. The generalized rule is written here, x to the m times x to the n. Notice that my base of x is the same in both terms, equals x to the m plus n. So if we apply this rule to example 6, I have x to the 6th times x cubed means x to the 6 plus 3, or x to the 9th. A very, very quick review on multiplying exponents or terms with the same base. If you have any questions, we can do a few more examples in class. Next, we're going to move on to a method of multiplication that I'm sure most of you will remember from Algebra 1. Sometimes when we're multiplying functions, it's necessary for us to find the product of two binomials or two expressions that have two terms each. The product can be used by a method called FOIL. And I'm sure most of you remember that from 9th grade algebra. And it's just based on the distributive property. Just like our order of operations, please excuse my dear Aunt Sarah, reminds us of what to do each step along the way, FOIL's the same thing when we're multiplying binomials. F stands for first. That tells us to multiply the first two terms in each binomial. O stands for outer, and that tells us to multiply the outside terms. I stands for inner, and you'll never guess, the inside terms. And then finally, L stands for last, so we're going to multiply the last two terms. So first, outer, inner, last, when we multiply two binomials. Next, we're going to take a look at example 7, where we're going to apply both FOIL and the multiplication rule of exponents when we multiply f and g of x. The first step in multiplying two functions is to replace that function notation with the equivalent expressions. So I'm going to replace f of x with 3x plus 8 and g of x with 2x minus 12. Noticing that I have two binomials that I'm multiplying together, I'm going to use FOIL. And FOIL is first, outer, inner, last. So multiplying those first two terms, I'm going to have 3x times 2x. Next, O for outer, I'm going to have 3x times negative 12. I for inner, 8 times 2x. And finally, last, 8 times negative 12. Now, I wrote this line out, and you're more than welcome to write this line out if it helps you to stay organized and to make sure you've included all your terms. If, however, you can do this part in your head, go right ahead and skip step 2 and just write step 3 down. So, when we're multiplying the two terms here, remembering when I multiply terms, I'm going to multiply the coefficient. 3 times 2 is 6, and x times x is x squared. Moving on, 3 times negative 12 is negative 36, and I have a single x. The third term, 8 times 2, is positive 16x, and then my last two, 8 times negative 12, is negative 96. My last step is to simply combine my like terms. So I'm going to combine my two like terms, which are negative 36x and 16x. So I have 6x squared. Negative 36 plus 16 is negative 20x minus 96. So the product of f of x times g of x is 6x squared minus 20x minus 96. Please pause the video now and give example 8 a try. Make sure you turn the video back on in a few minutes when you're finished and check your solution. Okay, let's see how you did. Example 8 says to find c times d of x, where c of x equals x minus 2 and d of x equals x squared. Step 1, replace the functions with their expressions. So I'm going to have x minus 2 for c, x squared for d of x. They're not both binomials, so I'm just going to use the distributive property to help me find the product. And all that is I'm going to take each term in my first expression and multiply it by each term in the second expression. And this time it's only the one term in that second expression. So I'm going to have x times x squared. Then I have negative 2 times x squared. Now I multiply together, and x times x squared, when we don't see an exponent, there's always a 1 there. So that's the 1 plus 2. So that's x cubed. Negative 2 times x squared is minus 2x squared. So we have x cubed minus 2x squared as the product of c of x times d of x. I hope you did well with that. We're going to do more practice problems in class, some more difficult than this with many more terms. So don't hesitate to ask for assistance, and we'll work through this and make sure everybody knows how to multiply functions. And before you come to class next time, please complete the one to more multiplication example on your note-taking guide and complete the online self-check and print out those results to bring to class. Until next time, have a nice evening, and we'll see you in Algebra 2.